Alright, in this presentation, we are going to be talking about solving logarithmic equations. A couple things that we want to remember. Remember our definition for a logarithm, how it relates to an exponential. We'll be using that throughout the presentation. Some other rules that we do need to remember is that we can combine logarithms that are being added together by multiplying the insides, and we can combine logarithms that are being subtracted by dividing the insides. Things to note and or remember while doing this section. We want to remember how to solve a linear equation. In order to solve a linear equation, we want to move variables and constants to opposite sides of the equation, divide by the coefficient. We will also want to remember how to solve quadratic equations. In order to solve a quadratic equation, we want to move everything to one side, factor, set each factor equal to 0, and solve. To solve a rational equation, we want to clear the denominators and finish solving using either linear or quadratic techniques. One new thing that we want to remember, the domain of a logarithm is x is strictly greater than 0. So just like we did when we solved rational equations and radical equations, we will need to check our answers. If you have any values that you find while solving that make the inside of a logarithm 0 or negative, then the value must be discarded. It is extraneous. So let's go ahead and start out with some basic logarithm examples. If we look at example A, we have log base 4 of 8x minus 6 equals 3. The first thing that we want to do is we want to convert this to an exponential. So remember, we do our around the world. We get 4 to the 3 equals 8x minus 6. Let's go ahead and evaluate the exponent. 4 cubed is 64. From here, we want to go ahead and solve a linear equation. Since all of my variables are on the right, I want to move my numbers to the left. We get 64 plus 6 is 70 equals 8x. And then we can divide by 8. We should go ahead and simplify the fraction. And if we simplify it, we can divide both top and bottom by 2, giving us 35 over 4 equals x. Now, in order to check this, all I want to make sure is that the inside thing is greater than 0. So if we multiply 8 times 35 over 4 minus 6, I just want to know, is this negative or is it 0? Well, 8 times 35 over 4 will give us 70 minus 6, and 70 minus 6 is 64. This is positive, and so it does check out. We have a nice answer. Well, I don't know if you would call it nice, but we have a working answer. Let's look at example B. Example B, we have log base 2 of 8 minus 6x equals 5. So if we go ahead and solve, we get 2 to the 5th equals 8 minus 6x. 2 to the 5th is 32. My right side stays the same. And then I can go ahead and finish solving. So we can subtract 8 from both sides. We get 24 equals negative 6x. And then if we divide by negative 6, we get negative 4 equals x. Now, one thing to note is that the inside of the logarithm has to be positive, but our answers can be negative as long as they work out in the original problem. So if we plug this into our 8 minus 6x, we get 8 minus 6 times negative 4. Negative 6 times negative 4 is 24, and we get 32. Since 32 is positive, we are taking the logarithm of a positive number, and therefore negative 4 is a perfectly fine answer. These are some basic ones, so now let's go ahead and look at some that are a little bit more complicated. If we look at example C, we have log x plus log of x minus 3 equals 1. One of the first things that we want to do is we do want to use our product rule and combine this into a single logarithm. If we do that, we get log of x times x minus 3. Remember that when we have logarithms being added together, we can combine them into a single one by multiplying the insides. One of the other things to notice about this problem is that it doesn't have a base written in. Now, when I talked about the calculators, remember that I said that two of the most common ones, especially on the calculator, is the common log, which has just log. The other one was natural log. We're not going to work with natural log. The common log, which is this one, has log with a base of 10. So let's go ahead and write that in so that we can go ahead and now convert into exponential form. So if we convert this into exponential form, we get 10 to the first power equals x times x minus 3. My next step in order to solve this problem is I want to get rid of the parentheses. So I'm going to go ahead and distribute the x. We get x times x is x squared. X times negative 3 is negative 3x. And from here we need to decide, do we have a linear equation or a quadratic equation? As this is quadratic, remember that we want to move everything to one side of the equation and factor. I'm going to move my 10 to the other side because I prefer my x squared to be positive. So I'm going to subtract 10 from both sides, giving me 0 equals x squared minus 3x minus 10. This factors. We have x and x. And for 10, I want to go with 5 and 2. Since the 3 is negative, I want my larger number to be negative. So we have 0 equals x minus 5 and x plus 2. So now, if we set each one of these factors equal to 0, we get x minus 5 equals 0, or x plus 2 equals 0. For the first equation, we can add 5 to both sides, giving me x equals 5. And for the second equation, we can subtract 2 from both sides, giving us x equals -2. So now we want to check each one of these. So I'm going to start with 5. And remember, all that we care about is the inside of any of these logarithms 0 or negative? Well, if we plug in 5 into the first one, log of 5. 5 is positive. That's perfectly acceptable. What about 5 minus 3? 5 minus 3 is 2. 2 is positive, and therefore that's acceptable as well. So we do have x equals 5 is a solution. Let's do the same thing with -2. If I plug it in to the first one, I get a negative number inside my logarithm. That is not allowed. It also happens on the second one. And so what we have to do here is we want to discard x equals -2. Therefore, we only have one solution of x equals 5. Okay, let's look at one more involving addition. So again, the first thing I want to do is combine this into a single logarithm. So we get log base 2 of x minus 3 and x plus 3 equals 4. If we go ahead and convert to exponential, I have 2 to the 4th equals x minus 3, x plus 3. We want to multiply our factors together as well as simplify the exponential. So 2 to the 4th is 16. We have difference of squares here. Notice that your factors are exactly the same except for the signs. So we get x squared minus 3x plus 3x minus 9, or just x squared minus 9. This is quadratic, which means I need to move everything to one side of the equation. So I'm going to subtract 16 from both sides. I get 0 equals x squared minus 25. And now I can go ahead and factor this. This is difference of squares. So we get x minus 5, x plus 5. If we set each factor equal to 0, we get x minus 5 equals 0, x plus 5 equals 0. And now when we solve each one of these little equations, we get x equals 5. We can subtract 5 on the second one, giving us x equals -5. Okay, so now let's check our answers, starting with 5. If we plug in 5, 5 minus 3 is 2. That's fine. 5 plus 3 is 8. That is also fine, because they are both positive numbers. So x equals 5 is a solution. If we try the -5, -5 minus 3 is -8. And recall that we cannot have negative numbers inside square root, or inside logarithms, sorry. And therefore, we can go ahead and discard this. So there are some examples of basic ones as well as ones involving addition. A couple more examples that we want to look at. involves logarithms and subtraction. So let's go ahead and dive into these and see what we can do with them. If we look at example E, we have log of x minus log of x plus 7 equals 1. Again, the first thing that I want to do is combine it into a single logarithm, and remember that subtraction turns into division. So if we have subtraction, this is going to become log of x over x plus 7 equals 1. We want to go ahead and convert to exponential. Again, since there is no base written in here, it is base 10. So we get 10 to the 1 equals x over x plus 7. We want to evaluate our exponent. 10 to the 1 is just 10. And we have x over x plus 7. The next thing we want to do is clear the fraction. So I'm going to multiply both sides of my equation by x plus 7. On the right side, they cancel out. On the left, we need to distribute the 10. We get 10x equals 70. Sorry, 10x plus 70 equals x. This is a linear equation. Since all of my constants are on the left, I'm going to move all of my variables to the right. We get 70 equals negative 9x. And if I divide by negative 9, I get x equals negative 70 over 9. If we check this, the first one, log of x, just by plugging in negative 70 over 9, we automatically have that we're taking the logarithm of a negative, which means that we need to discard our only solution. Since there is not a value, since there is not a single number out there that will satisfy this equation, we did all of that work just to reach an answer of no solution. Let's look at example F. Example F, we have log base 4 of x plus 6 minus log base 4 of x equals 2. So the first thing that we are going to do is we are going to combine to a single logarithm. We get log base 4 of x plus 6 over x equals 2. Since it's subtraction, we change it to division. From here, we can go ahead and convert to an exponential. So we get 4 squared equals x plus 6 over x. Let's go ahead and evaluate the exponent. 4 squared is 16. We still have x plus 6 over x. I want to get rid of the fraction, so I'm going to multiply both sides of my equation by x. On the right side, they cancel. I am left with 16x equals x plus 6. I need to subtract x from both sides. Since this is linear, we're going to get, since all of my constants are on the right, I want to get all my variables on the left. We get 15x equals 6. I can divide by 15, and then I can simplify the fraction. We can divide by 3 to top and bottom. We get 2/3. Okay, so now if we check our answer, we get 2/3 plus 6. Is it 0 or is it negative? No. That's 6 2/3. That's a positive number. Log base 4 of 2/3. Same thing. 2/3 is a positive number. And therefore, we have a solution of x equals 2/3. Let's look at one final example. For this one, we want to start by moving all of our logarithms to one side so that we can combine them into a single logarithm. So I'm going to subtract log base 2 of x minus 3 from both sides. We get log base 2 of x plus 3 minus log base 2 of x minus 3 equals 4. I can now go ahead and rewrite this as a single logarithm. We get log base 2 of x plus 3 over x minus 3 equals 4. Since it's subtraction, I convert it to division. Now if we go ahead and convert to exponential, we get 2 to the 4th equals x plus 3 over x minus 3. Let's go ahead and evaluate our exponent. 2 to the 4th is 16. I can multiply both sides by x minus 3. On the right side, they cancel, leaving me with just x plus 3. And on the left, I can distribute the 16, so I get 16x minus 48. From here, I want to get all of my variables. On one side, I'm going to move x from the right to the left. I also need to move all of my constants to the other side or to the right, so I'm going to move my 48. This gives us 15x equals 51. Okay. Finally, we want to divide by 15 and reduce the fraction. So we get x is equal to, 17 over 5. So now let's go back and check this in our original problem. 17 over 5 plus 3, positive plus a positive is positive, so we're fine there. 17 over 5 minus 3. 17 over 5 is 3 and some change, and if you subtract 3 from that, you do get a positive number. And so this is our solution. So hopefully this makes solving exponentials and logarithmic equations a little bit easier. You should be able to go ahead and complete assignment 9.6 now. There will be one more video that I will be posting that covers Word problems. There is no examples of this in the homework, but we will see them on the final exam.